Chapter 7 is what we're dealing with in this playlist, and we're dealing with algebraic fractions and dividing polynomials, which fit together quite nicely. And what you'll find is that halfway through this chapter, it suddenly turns into a chapter all about proof, which is a bit of an odd thing. I suggest that the way we deal with this is think about it as two short chapters. There's section 7.1, 2 and 3, and then section 7.4 to the end of the chapter. And we just think of those as separate topics, because conceptually they're just completely different things, but I suppose the number of exercises that the textbook authors had in mind, they decided to stick them two together to make them into a chapter. So section 7.1 we'll deal with very quickly, and this is algebraic fractions. Really it's GCSE style algebraic fractions. All I'm going to do is give you a couple of hints. First of all, when you've dealt with whatever you're going to do on the algebraic fractions, you've simplified them as far as you can, try and factorise the top and the bottom, because if there are common factors, then they'll cancel out. So for example, D on this exercise here, factorise the top, factorise the bottom, and then we can see that x plus 5 is a factor of the top and a factor of the bottom, and we can cancel through by that. And the only other pointer is just follow normal arithmetical rules for fractions. So for example, if I have something like 5 over 7, I can write that as 2 over 7 plus 3 over 7. In other words, 2 plus 3 over 7 is equal to 2 over 7 plus 3 over 7. Okay, now that might seem a bit obvious, but when I've got something, just picking an example from the exercise here, 7x to the power of 5 plus, I've rewritten an example from the exercise here, but let's say I've got something like this, all divided by x. Well, I can think of that if I want. If it's useful, I can think of that like this. I can split it up and I can put as 3 fractions over the same denominator. Okay. The mistake that people make is where I've got something, for example, 4 over x plus y. They think, oh well, I can split it up here, so I can split it up here in the same way. And that is not true. Okay, and the reason why not is, let's just go back to this example over here. 5 over 7 is not the same as 5 over 4 plus 5 over 3. I don't know why I can't write these neatly, but there we go. 5 sevenths is not the same as 5 quarters plus 5 thirds. Okay, so we know it's true for fractions. We can see it's true for fractions. When we're dealing with algebra, we're just following the rules of the fractions. So just bear that in mind. If there's anything you're not sure whether you can do it or not, try and relate it back to numerical fractions. Watch out for that mistake, because that's one that we see a lot. And when you're finished dealing with your algebraic fractions, try and factorise the top and factorise the bottom in case there are any common factors. Other than that, you need to be able to do all GCSE algebraic fractions as smoothly and efficiently as you can. That's the end of section 7.1, 7.2 in a new video.